Hello everyone, welcome back to another video in C++ programming series. In today's video, we are going to explore the three-way comparison, also known as a spaceship comparison operator, which is introduced in C++20. We will explore the significance of this operator, its return type, and also we'll have a look at some real-life examples. So, with no further ado, let's jump right in. This is a C++ class named point. It represents a point in three-dimensional space. As you can see, it has three private member variables, m_first chord, m_second chord, and m_third chord to store the coordinates along the x, y, and z axes respectively. Next, we have a constructor that allows us to initialize these coordinates. By default, if no values are provided, the point will be at the origin 0, 0, 0. Now, let's look at the member functions. We have 6 in total. The first 3 are non-const member functions x, y, and z, which allows us to access and modify the coordinates. They return references to the respective coordinate variables and they act as setters. The next 3 functions with the const keyword indicate that they are const member functions, meaning they do not modify the object's state. They simply return the values of the coordinates. Now, why is this important in the context of operator overloading? Before the introduction of the spaceship operator in C++, if we wanted to perform comparison between point objects, we had to explicitly define all the comparison operators such as less than, greater than, less than or equal, greater than or equal, equality, and inequality. This meant writing a considerable amount of boilerplate code. In C++20, we can use a spaceship operator. The three-way comparison operator, also known as a spaceship operator, whether defaulted or not, is called whenever values are compared using less than, greater than, less than or equal, greater than or equal, or the three-way comparison operator itself, and overload resolution selects this overload. But what about equality and inequality operators? In C++20, the equality operator implies the inequality operator. Thus, we just need to define the equality operator. But still something here is vague. How does the defaulted three-way comparison work? The default three-way comparison operator performs lexicographical comparison by successively comparing the base left to right, depth first, and then non-static member in declaration order to compute the three-way comparison. It recursively expands array members in order of increasing subscript and stops early when a non-equal result is found. That's it. In our point class example, the defaulted three-way comparison operates in a systematic manner. It begins by comparing the m_first chord values between two instances of point classes. If these values are not equal, the comparison concludes and returns the result. However, if they are equal, the compiler proceeds to compare the m_second chord value. Again, if they are not equal, the comparison result is returned. If they are equal, the comparison extends to the third member, m_third chord. Finally, if all three members are equal, the comparison ultimately returns that the instances are equivalent. This process ensures that the comparison is conducted in a consistent and ordered manner. considering each member until a conclusive result is obtained. Alright, here is a unit test to clarify the defaulted three-way comparison. We have 4-point objects: origin, point A, point B, and point C. Origin is at the coordinate 0, 0, and 0. Point A is at 0, 1, 0, and point B is at 0, 0, 1. Point C is also the origin. Now, let's go through the assertions one by one. The first assertion is checking the result of three-way comparison between origin and point A. Since the m_first chord of origin and point A are both 0, it moves to the next member, m_second chord. Here, origin has 0 and point A has 1. So origin is considered less than point A. In the second assertion, we are comparing point A and point B. Again, it starts with m_first chord. Since they are both 0, it moves on to the m_second chord. Here, point A has 1 and point B has 0, so point A is considered greater than point B. Finally, the third assertion compares point C and origin, both at the origin. So all three coordinates match. This means that point C is equivalent to origin. The new three-way comparison operator doesn't return a simple Boolean value. Instead, it operates akin to three-way comparisons, providing a negative value to indicate less, a positive value for greater, and 0 for equal or equivalent. This behavior resembles the return value of the C function strCompare. However, there is a crucial distinction. The return value is not an integral type. Instead, the C++ standard library offers 3 distinct return types, each corresponding to the category of the comparison. To answer the question, what does three-way comparison operator return, we first need to look at these categories. In a strong ordering, also known as total ordering, any value within a given type falls into one of 3 categories. It's either less than, equal to, or greater than any other value of the same type, including itself. This concept is exemplified by integral values and common string types. For instance, when comparing 2 strings, S1 will either be less than or equal to S2 or greater than S2. If a value doesn't fall into the less than or greater than categories, it must be equal. In scenarios involving multiple objects, you can arrange them in either ascending or descending order with equal values holding any position among themselves. In a weak ordering, every value within a given type falls into one of the 3 categories. It's either less than, equivalent to, or greater than any other value of the same type, including itself. It's important to note that equivalent values may not necessarily be equal in value. A classic example of this category is a type for case-insensitive strings. For instance, the string hello is considered less than hello1 and greater than hell. Interestingly, hello is deemed equivalent to hello all in uppercase, even though these 2 strings are not strictly equal. If a value doesn't fall into the less than or greater than categories, it is categorized as equivalent. When dealing with multiple objects, you have the option to arrange them in either ascending or descending order. with equivalent values holding any position among themselves. In the realm of partial ordering, values within a given type can fall into one of three categories. They can be less than, equivalent to, or greater than other values of the same type, including themselves. However, there may be instances where it's impossible to definitely establish an order between two values. A classic example illustrating partial ordering is found in floating point types, which can include a special value called nan, or not a number. When nan is involved in a comparison, the result is invariably false. Consequently, in such cases, a comparison might determine that two values are unordered, leading the comparison operator to return one of the four possible values. In scenarios involving multiple objects, it might not always be feasible to arrange them in a strict ascending or descending order, especially if there are values that cannot be definitely ordered. For the different comparison categories, the C++20 standard introduces the following types: std strong ordering with the values std strong ordering less, std strong ordering equal, also available as std strong ordering equivalent, and std strong ordering greater. Then we have the std weak ordering with the values std ordering less, std ordering equivalent, and std weak ordering greater. And finally, we have std partial ordering with the values std partial ordering less, std partial ordering equivalent, std partial ordering greater, and std partial ordering unordered. Note that all types have the values less, greater, and equivalent. However, partial ordering has also the value unordered, representing neither less nor equal nor greater. Stronger comparison types have implicit type conversion to weaker comparison types. That means you can use any strong ordering value as weak ordering or partial ordering value. Here's a unit test that showcases the different return types of the three-way comparison operator. Let's break it down step by step. First, I should note that three-way comparison operator is defined for all fundamental data types for which the relational operators are defined. We have three sets of comparison going on here. First, we have two integers, x and y, with values 3 and 4 respectively. The comparison between x and y returns std strong ordering less, indicating that x is less than y. Next, we have two doubles, q and p, with values 17.3 and 32.8. The comparison between p and q yields std partial ordering greater, signifying that p is greater than q. Lastly, we are comparing two strings, hello and C-style string hello. The result of this comparison is std strong ordering equal, indicating that these two strings are considered equal. Now, let's have a look at an example in which we define the three-way comparison operator ourselves. First, let's have a look at the line class. It has two private members, m_first_point and m_second_point, which are both of type point. The constructor takes 2 points objects, start and end, and initializes the m_first_point and m_second_point members. Next, we have a function called length, which calculates the length of the line. We won't go into the details of this function for now, but it's an essential part of the line class. Finally, this class has two operators, the equality and comparison operators. Now, let's have a look at the definition of these operators. Here, we have the definition of the equality and three-way comparison operator for the line class. Let's take a closer look. The equality operator checks if the length of two lines are approximately equal. It uses the fabs function, which returns the absolute value of a floating point number. If the absolute difference between the length is less than 1e minus 9, the lines are considered equal. Now, let's discuss the three-way comparison operator. This operator returns a std partial ordering type, which indicates the relationship between the length of two lines. Instead of manually checking if one length is greater, less than, or equal of the other, we utilize the three-way comparison operator. This operator is mapped to the result of computing the lengths, which are both of type double. So, why do we use these operators? Well, by implementing them, we make it much easier to compare lines based on their length. It's a cleaner and more efficient way to handle these comparisons. Let's see an example in action. Suppose we have two lines, line A and line B. We can simply use the equality operator to check if they are approximately at the same length, and the three-way comparison operator to determine their relationship. As you can see, by utilizing these operators, we can streamline the process of comparing lines, making our code more concise and readable. Okay, before we wrap up, I want to let you know that example codes we have discussed today are available for you to explore in our GitHub repository. You can find the link to the repository in the video description down below. It's a great resource for you to dive deeper into the concepts we have covered. I've used CMake to build the code and GoogleTest for creating the unit test. Thanks for joining me today. We explored the fascinating world of a spaceship operator in C++20. I hope you found this video valuable and informative for your coding journey. If you enjoyed the video, don't forget to give it a thumbs up and subscribe to my channel. If you have any questions or any other topics that you would like me to cover in future videos, please leave a comment down below. I would love to hear from you. Until next time, happy coding!